Hi everyone. Last week we talked about arithmetic sequences. This week we're going to talk about geometric sequences. So a geometric sequence is, again, it's a sequence of numbers. It's a list of numbers in which a constant can be multiplied to each term to get the next term. So last week we had series where we were adding something. This week we're going to multiply. And that constant that we're using to multiply is called the common ratio, and we abbreviate it with the letter R. To find the common ratio, we use division. So it's the second term divided by the first term. So in this example, we have negative 10 divided by 2, we get negative 5. And we can check that by multiplying it through. So we've got 2 times negative 5 is negative 10. Negative 10 times negative 5 is 50. 50 times negative 5 is negative 250. So it checks. So here's a few examples. We're going to see if they're geometric, and if they are, we're going to find the common ratio. So this is our first one. So is there something we can multiply to get this sequence? And yes, there is. And if we take our second term divided by the first term, we just get 6, and that's our common ratio. So 1 times 6 is 6. 6 times 6 is 36. 36 times 6 is 216. How about this one? Is there something we can multiply all of these numbers to get the next one? And now the answer is no. There is no common ratio. This is an arithmetic sequence, right? We would have a common difference of 2. We're adding 2 to get to the next number. So our formula for a geometric sequence looks like this. We've got a sub n, like we had before, a sub 1, that's our first term. Now instead of a difference, we have a ratio, and we're going to raise that to the n minus 1 power. So a sub n is the nth term in the sequence. A1 is the first term. N is the number of the term. And R is the common ratio. So let's look at an example. So here's a sequence, and it says find the 19th term, and it tells us it's geometric. So we're going to start with that formula, this formula, and then we're going to find the common ratio. So our second term is 33 divided by our first term is 3, and that's our common ratio. And then I plug what I know into the formula. So I need the 19th term. That means that n is equal to 19. And my first term is 11, right? So I know that's a sub 1. So A19, my 19th term, is equal to 11 times 3 raised to the 19 minus 1 power. Now, the next step, it says to simplify. Let's talk about how to put this in the calculator. So 19 minus 1 is 18. Hopefully we can all do that in our heads. Then the next thing to do is to put the x, we do exponents next, right? Parentheses first, so that's this, and then the exponents. To put that in the calculator, we do 3 and a caret and 18 and hit enter. And then after we have that answer, then we're going to do the times 11. And if you've done it correctly in the correct order, you should get this answer. And yes, it's a really big number. Geometric sequences grow very quickly. And that's it. That's how it works.